This is happening.
Okay, here we go. What we're going to do is take this to the next step. So far, all you've learned how to do, hopefully, in section 1, you learned how to find the derivative using the limit process. You will still have to know that definition and be able to take derivatives as you do problems from section 1. In section 2, you learned the shortcut, otherwise known as the power rule. But the power rule had some limitations to it. I told you that you couldn't use it if there was a product of variables, and you would have to manipulate your equations to be able to do it. So I want to show you an example of what I mean. If I had the function x to the 5th plus 2x to the 4th, and I was trying to find its derivative, using the power rule, I think every single one of you could do that. Using the power rule, what would the derivative be?
5x to the 4th plus 8x to the 3rd.
Yeah.
Do we all agree on that?
Yeah.
Okay. So, let me show you something and really try to hit home a concept here. Okay? F of x is also the same thing as this. Let's see if you agree with this. Is that f of x the same thing as x to the 3rd times x squared plus 2x? Is that the exact same thing as f of x?
Maybe.
Yeah.
Theoretically,
Yes, yes.
Aren't those equivalent?
Yeah.
Because you would add exponents when you multiply or distributed this through. Okay, so let's look at what would happen if I try to take the derivative of this piece and this piece. If I try to take the derivative of this piece, the derivative would be 3x squared, right? If I try to take the derivative of this piece, it would be 2x plus 2 of just this piece, of just this parenthesis. Now, is that the same thing as 5x to the 4th plus 8x to the 3rd?
No.
They're not equal. So that means that I cannot use the power rule when it's when there's two variables that are multiplying each other, when there is a product. So there is a special rule called the product rule that will help us do things when there is a product of variables. So I'm going to come back to this in just a second, but let's write down what the product rule actually says. The product rule says this: the derivative with respect to x, that's what d over dx stands for, of f of x times g of x is going to be equal to f of x g prime of x plus g of x times f prime of x. Woo! This is the product rule. This is how it says it in the book. Arsha? Absolutely. Because the addition property is commutative, you can actually have this part first, or you can have f prime of x times g of x plus f of x times g prime of x. Absolutely. Either way is correct. But here's what I basically do, because you are expected to memorize this. This is not how I have it memorized. I have it memorized completely different. I have it memorized like this: 1d2 plus 2d1. 1d2 plus 2d1. It kind of has a little ring to it to me. 1d2 plus 2d1.
I think I'm starting to hear that ring.
1d2 plus 2d1. Here's what it means. You take your first thing. You want to treat. Let's go back to that problem up here that didn't work out for us. Let's treat it like this is f of x, and let's treat this like it's g of x. Like this is one set of variables, and this is the other set of variables. This formula would be, okay, you write down f of x, you write down x to the third, f of x. Then you're going to multiply it by the derivative of g of x. The derivative of g of x was 2x plus 2. So this is f of x. This is g prime of x plus, what's g of x? X squared plus 2x. What's f prime of x? 3x squared. Why does it have to be so complicated? Trust me, you'll like something in just a little bit. But let me get to the big surprise in a second. Okay? Okay. If we were to this is what I mean. 1d2 plus 2d1. 1 was the first thing, the x to the third. d2 stands for the derivative of the second thing. Did I do the derivative of the second group? 2x plus 2. See how that's the derivative of the second thing? Plus 2, what's the second thing without taking the derivative? Times d1, the derivative of the first thing. 1d2 plus 2d1. Let's simplify this. Since this is multiply, let's distribute that and get 2x to the third, to the fourth, I'm sorry, plus 2x to the third. That's what this first group would be. The second group would be, after I distribute it, would be 3x to the fourth plus 6x to the third. And if I put those two things together, I would get 5x to the fourth plus 8x to the third. Do you see how this answer now is equal to the derivative that we found the other way? Okay? The other way is easier. There will be problems that you cannot do the other way. That this way is going to be the easiest way. That's how it works. We're going to be having to use this because we're going to get really complicated, especially when we have like sine of x and cosine of x and products of sine of x and cosine of x and things like that.
Mr. Promo.
Yes?
Where did the 3x squared come from? I'm kind of confused on
This
that.
piece right here?
Yes. Or actually that
One.
whole, like that half right there. Yeah, like the x squared plus 2x
Okay.
and then times 3x squared.
I use the formula of 1
Uh-huh.
d2, this is d2, plus 2, this is the second one, that's 2, and the d1 was the derivative of the first piece. Think of f of x as the first piece and g of x as the second piece.
Oh, okay.
1d2 plus 2d1. That's what
okay.
that is.
All right.
Other questions? Okay. Now the grand surprise, the thing that I want you all to know. You can leave your answer just like this
Yes.
when you
that
get to the
is
problem.
Oh,
biggest
God.
surprise.
You will not have to simplify these problems. In Calculus AB and in Calculus BC, Mr. Foster and Mrs. Pape teach that for the AP test, if you make an algebraic mistake, you will probably get the question wrong. So this answer is going to be the derivative of that. You just haven't simplified anything. In calculus, it's okay to have the derivative without simplifying. And since this derivative is correct, you don't have to simplify it. They actually recommend leave it alone. Don't do the algebra. Don't do the simplification because you might make an algebraic mistake. You're more likely to pass the AP test without simplifying than you would be with simplifying. So here's my warning to you about that. I am going to accept this answer on all quizzes and tests. Your homework will not have answers in the back of the book, will not look like this. Your answers in the back of the book will look like this. So you're going to have the faith that you've done it correctly, but if you are unsure, then you're going to want to have to go through it to check your answers in the back of the textbook. That's what's going to happen. Make sense? What do I want on your quizzes and tests? Right here, the same as Calculus AB teachers and Calculus BC teachers. Got it? Are you ready to practice one?
Yeah.
Maybe.
Here it is.
Maybe.
Here's example 1.
Example 1.
H of x is 3x minus 2x squared times 5 plus 4x. I want you to find the derivative of h of x. With the neighbor, you may compare your answers after you find it. Hopefully you're going to use the formula. Hopefully you know how to do the formula easily. And I will randomly select a few of you to see. I'm going to stop the recording.